All right, today we are going to work on solving graphing linear inequalities. And so these are going to be where we are graphing a line that has an inequality symbol rather than an equal sign in it. And so basically what's happening is that we're going to graph our line on a graph, and then we're going to have a shading that shows which side of the line causes something to be true. And so here, an ordered pair that is a solution makes an inequality true when I plug my numbers in it. And so when I do something like this, so if I want to see whether these ordered pairs are a solution to this inequality right here, so all I want to do actually is plug in the ordered pairs, the x in for the x and the y in for the y, and then see if it gives me a true statement or not. So when I do this first one, I am going to plug in the ordered pair 0, 0 into this equation right here, this inequality. And so all I'm going to do, and actually I'm going to rewrite it so we can see, I'm just going to substitute in a 0 for my x and a 0 for my y. So I have 2 times 0 minus 3 times 0 is greater than or equal to negative 2. And so when I do this, again, 2 times 0 gives me 0. 3 times 0 gives me 0. And 0 minus 0 is also going to give me 0. And so what I can do here is I just want to see whether this is true or not. So again, the way that you learned this way back when is the alligator eats the bigger number. And so this one is eating the 0. Is 0 bigger than negative 2? That is true. So that means that the ordered pair 0, 0 is a solution. I can do the same thing with this second one. The ordered pair 0, 1. I can plug in a 0 for x and a 1 for y. So I can go 2 times 0 minus 3 times 1 is greater than or equal to negative 2. Again, 2 times 0 gives me 0. 3 times 1 gives me 3. Subtracting those from each other. 0 minus 3 gives me negative 3. And so again, what I'm thinking here is negative 3 bigger than negative 2? That is false. And so this would not be a solution. And then this last one here, I'm going to do the same thing. I'm going to go 2 times 2 minus 3 times negative 1 is greater than or equal to negative 2. So when I do this, I get 4 minus 3 times negative 1 gives me negative 3. And so again, remember that this minus a negative is the same thing as a big plus sign. So 4 plus 3 gives me 7. It's greater than or equal to negative 2. And again, is the alligator eating the bigger number? Is 7 bigger than negative 2? That is true. And so that means that this ordered pair is a solution. Okay. So that's just seeing whether something is a solution or not. And so where we're going to spend most of our time at today is we're going to graph inequalities. So when we graph an inequality, we're going to have a dotted or a solid line and then a shaded side. And I'll kind of get there, but a dotted line is going to be where points on my line are not included as a solution. And then a solid line ends up being all my points on my line are included. And then my shaded side, all the side that I shade ends up being numbers that make my inequality true. And so the way that this works is we will use Desmos for this, but just as a way of kind of knowing this, we're going to highlight with me if you could graph the line like it's an equation. So I'm going to get y by itself. I'm going to use a table, or I'm going to use my slope and y-intercept. And then once I graph my equation, if my inequality sign, so if I have a less than or greater than sign, noticing that there's not a line underneath it, that means that my line will be a dotted line. That's going to tell me that points that fall on my line are not a solution. they are not a solution to my inequality. And then if I have a less than or equal to or greater than or equal to, those will have a solid line. And that's because I have the or equal to, the line underneath of my inequality sign. And that'll tell us that points that fall on my line are solutions to my inequality. And then the next thing that I have to do after I graph it and I have my dotted or solid line is I have to see which side to shade. And actually the way that we're going to do that is we're just going to use Desmos. And so when I do this, this first one over here on the left-hand side, I have the inequality x is less than or equal to 4. And so when I go over here to Desmos, I'm going to type in x's. And I'm actually going to start with putting that it's equal to 4 because I want to be able to see my line to know how I'm going to graph it. So here I've got a vertical line right there at 4 right of my middle of my graph. So I know I'm going to have a vertical line. Then I can go ahead and I can replace it with it was less than or equal to, right? Yeah, good. So I've got my line here. It is a solid line, solid vertical line, and it's shaded to the left. And so what I can do is put my dot there. This is a solid line right there. There's my line. Again, I graph it just like I would if it was an equal sign. That's why I did the equal sign first. And then after that, then I know that I'm shading to the left. And so I can go ahead and I can shade to the left everything that's to the left of my blue line. And so, again, what this means is that any ordered pair that is on that blue line or in that shaded orange region is a solution. So if I look at this ordered pair right there, so if I look at the ordered pair 1, 1, and if I ask, is the ordered pair 1, 1 a solution to this inequality, I would say it is a solution. Oops. Because it's in my shaded region. Okay. The second one, I'm going to do the same thing. So y is greater than greater than 2. So I go y is equal to 2 first. Whoopsie. So again, I get a horizontal line there. So that tells me that's what my graph is going to look like. And it's just greater than. There we go. So again, notice that on Desmos, I've got a dashed or a dotted line. So I'm going to go here to above my origin, and I'm going to do a dashed line or a dotted line. Again, that continues on forever and ever. And then I am going to shade above my line. So everything that is above my blue dotted line ends up being a solution. And so again, what I can do is I can put the ordered pair 1, 1 there. And I can say, is the ordered pair 1, 1 a solution to my equation? And I would say it is not a solution because it is not in my shaded region of my graph. Everything above my dotted line is a solution. Everything that is not shaded is not a solution. And then I can do the same thing with the last one. X is greater than or equal to negative 3. Again, I'm going to graph it just like it is an equal sign first. See that I've got a vertical line there, and then I'm going to go ahead and change it to a greater than or equal to sign. Just like that. There you go. So it's a solid line, solid vertical line. Whoops. Like that. And I am shading everything to the right of that line. Sometimes the mistake that we make is that people will stop shading or where the y-axis is or one of the axes is. Just know that it is everything to the right of that blue line. And so again, if I use that same ordered pair 1, 1, Is 1, 1 a solution? It is a solution. Because it's in my shaded region. Okay. So there's that. You can go ahead and flip over to the back of your notes. We got 3 of these to go through. And so when we do this, the first thing that I'm going to do is I'm going to get my y by itself, because to graph anything, I want to get my y by itself. I can either use my table in Desmos, or I can use my slope and my y-intercept. So when I do this, if I want to get my y by itself, I'm going to subtract the 2x over to the other side. Get y is greater than 2 minus 2x. And so the 2 different ways I could do this is, let's see, my slope is negative 2 over 1, which tells me that I'm going down 2 and right 1. And my y-intercept is positive 2, which tells me that I start 2 above my graph. If I want to use a table instead using Desmos, I can do that as well. So I'm going to graph this like y is equal to 2 minus 2x. Like that. And actually I could just graph those 2 points, but I can use my table. Negative 2 through positive 2. I've got 6, 4, 2, 0, and negative 2. Start at 6 and goes down each time. And so regardless of which way I do it, if I'm using my table and graphing those points, or if I'm starting at 2 and then going down 2, right 1 each time, or if I'm using my table and I'm graphing, this is my left or right, this is my up or down. Negative 2, 6 is left 2, up 6, which is that point right there. Negative 1, 4 is left 1, up 4. 0, 2 is don't go left or right at all, and just up 2. There's my graph. Once I get my points down, now I want to figure out, is this a dotted or a solid line? And I hit the undo button there to get out of my table, or you can just retype in your equation. But what I want to do is I want to change this to my inequality sign. So I go to just a greater than sign. Oops. Like that. And so when I see that, I see that it is a dotted line. So when I connect these guys together, I'm going to do a dotted line or a dashed line. And then I know that my shading is going to be there we go, yep. So I'm going to shade this part of my graph. Just like that. And so again, I could look at that ordered pair 1, 1 right there. Ordered pair 1, 1. You can see it's part of the shaded region, so it is a solution. Second one, I can do the same thing. Get my y by itself, so I'm going to add the 8x to the other side. So y is less than or equal to. I added the 8x to the other side. I then divided everything by 4 to get my y by itself. My slope is 2. My y-intercept is negative 3. So my slope is telling me I'm going up 2 and then right 1 each time that I move. And so again, I can go ahead and graph this. So y is equal to negative 3 plus 2x. And again, the reason why I graph it with a equal sign first is because I can't get a table if I do it with the inequality sign. So there's my table. What was it? Was it negative 7? Yeah. positive 1. Yep, good. So when I graph it like this, negative 2, 7. And again, I'm just kind of continuing my pattern up as we go. Again, if I want to get back to see the inequality and where I'm shading, what I can do is I can go ahead and click out here. I can just retype it in. I can go y is less than or equal to. And then it is negative 3 plus 2x. There you go. Have a graph that looks the same. And that one has a decimal as an intercept, so I can't graph just the x and y intercepts. Should be a solid line that is shaded below it. Like that. And then it's shaded below. Like that. And again, I can look at that same ordered pair 1, 1. Is that a solution? It is not a solution. And the very last one that we have, again, same thing. I'm going to get my y by itself first. This one, if you put a little star above it, this one's a little bit tricky because when I get my y by itself, and this is something that is a little bit new for you guys, or maybe you just don't remember, but if I want to divide to get rid of that negative sign, I'm going to treat it like a negative 1. Excuse me. And if I ever divide both sides by a negative number, I need to flip my sign. So divide by a negative, I need to flip my sign. And so that gives me I flip my sign from a greater than sign to a less than sign. I get negative 3 plus x. So my slope is 1, and my y-intercept is negative 3. So when I go to graph this, again, my y-intercept, I'm starting 3 below my origin, and I'm just going up 1, right 1. I can then graph this to see if it's dotted or solid and which side to shade. So there's a dotted line and I'm shading below it again. So I can do that dashed line. And I can shade everything that's below it. Again, I can ask that same question. Is 1, 1 an ordered solution? It is not a solution because it's not in my shaded region. So again, I'm getting my y by itself. I'm graphing it like it's an equation, like it has an equal sign. And then I can use Desmos to figure out whether it is a dotted line, solid line, and which side to shade.